If you had to just give one word of hope and encouragement for educational leaders, what is your one word of encouragement to them?
I think they should use AI, learn to use in a fascinating way, not to be afraid that a lot of tasks they are doing can be accelerated. They can never replace their expertise and their multiple years of experience. And they have to learn to teach the students, actually, to have the joy of learning. When you solve the problem on your own, or you use the model in a meaningful way, and you do steps and progress, to have this amusement. A student using the LLMs this way can always be happy and satisfied and try more, to do more progress, to learn more things. I think educational leaders should take that into account and diffuse the passion for learning to the students.
All right, everyone. Welcome to another episode of the AI Math Guy podcast, where we reimagine public school teaching in the age of AI. Today, we have a very special guest. His name is Spiros, and he is a PhD candidate currently at Boston University. He has done a lot of work in the computer science discipline and in terms of safety and AI, things like bandit algorithms, and just a super intelligent and very well versed in AI. So very excited to have you, Spiros. Do you want to add anything, just a little bit about yourself before we start?
No, thanks so much. Thanks for inviting me. And it's my pleasure to discuss about learning in the era of AI.
Perfect. So tell me a little bit more about yourself. You're currently a PhD candidate in Boston, correct?
Yeah, that's true. I'm in my third year of my
Nice.
PhD. I study decision-making algorithms. So the bandit is like a name. It comes after the slot machines. Like you have multiple choices. Imagine multiple stocks or multiple slot machines, and you want to start taking decisions without any knowledge about which stock is the best one, and adaptively explore and find the best choice in in an online fashion.
Very
They
good.
call it online decision making in computer science. And
Very.
the opposite one is the offline, where you have all the data and you want to make some prediction based on the batch of data you already have stored. Yeah.
Wow, that's a lot of information right there. So it's just so that I understand, you work with algorithms,
Yeah. But
make
decision making.
decision-making algorithms. And so you're given a set of data. And so given a set of data, what is the best choice given an X amount of data? Is that correct?
Yeah, like on an everyday fashion. So an example is like, imagine every day you have to take a choice, an action. And the action maybe can be invest on this stock or save money. But you're not sure, how good is the stock, what's the reward, or and we are trying to develop algorithms to start learning, exploring, and after a while to do exploitation on your current knowledge about the unknown quantity, like the stock. Or there are the doctors, for example. The doctors have to give some dosage to the patient, but they are not sure how the patient is gonna perform under this dosage. So they want adaptively to both learn and assign good dosages to the patients.
So what you are saying, so for example, we have the stock example where you want to choose, I don't know, Tesla stock or hold your money. And in order for you to make that decision, you have to have information about Tesla or about, I guess, holding money. And then it also, like you're saying, is adaptive in the sense that I would imagine Tesla stock with news coming up or whatever is happening, it's memory of sorts. And so it's making decisions based on the best and most recent data that it has in its mind. And so
Yeah,
with is that kind of the idea?
yeah, that's exactly the idea.
Wow. I'm really surprised that I was able to articulate that, because as I was listening to it, I was like, okay, I'm following. And so then when it comes to like medical decisions too, right? You have a certain patient and they have a certain history of this diagnosis, and you want to, given all the data, make the best decision given what you know about the patient and about the diagnosis.
Or the current condition on the patient.
Sure.
Like in chemotherapy, I think that's the case that you have to think about the current condition on the patient to adjust the dosage.
Sure.
Or there are other examples where researchers are trying to find how good is a drug. And this is called the average treatment effect. And they want to design algorithms, they're offline algorithms or online one, and are trying to use the context. The context is like the current state of the patient. Maybe temperature or blood pressure, or the doctors usually select the features, and then you want to design algorithms to learn how good is the drug or what's the best dosage for this patient today or things like that.
So when you say that, okay, so you said that the context, and when you say context, am I understanding it to be like the context window of when you put something into AI, it kind of has like a working memory? Is that what you're referring to?
Yeah, like the features, people call them features sometimes. That's the feature may change, it depends on the application. And I think in practice, the experts are choosing the features. But there are also statistical methods to select which features are good or not. And then apply your algorithms using this model you constructed. And of course, like the models do not always explain everything. And it's a matter of art in practice to choose the right model or the right features or this stuff. Yep.
And when you say features, I know that you're not really referring to like when you look at software and there's like a bunch of features, like it's like a thing that this app can do. The way that you're using the word features is a little bit different, is it not?
Yeah, like in the patient example, imagine we are doctors and we take into account how good is the patient today? What's the blood pressure? What's the sugar? What's the temperature? Or maybe some indexes in the medical exams. So all these must be taken into account when we choose our current, let's say, chemotherapy dosage.
I see. So what you mean by features are like different quantities of information that you need in order for you to apply the best apply the algorithm,
Yeah,
correct?
that's
Okay.
exactly, yeah.
So it's like
These
blood
are called
pressure. Yeah.
contextual algorithms because there's some context in the decision upon taking the decision.
So this is called contextual algorithm.
Yeah, imagine Lyft or Uber when it proposes you a price. As far as I know, it collects some data from your record or maybe the current state of your phone, whatever the current state of the market. And based on that, they deploy an algorithm to propose you a price.
I see. So contextual algorithm is the context is different features. Features is basically different sets of quantities of information, whether it's blood pressure, iron levels, whatever. So these are different characteristics. And these
Yeah,
characteristics then become the context. And then the algorithm applied to that context is what you would call a contextual algorithm.
yeah, exactly.
Perfect. Okay. And I'm sure that does this have to do with like machine learning? I did a super quick thing on machine learning, and I think this is what machine learning is. Is that correct?
Yeah, yeah, right. So machine learning is like a very broad thing. I think machine learning is when you use like neural networks or large language models to apply your statistics. Like you have, some algorithms from statistics, and you want to find the appropriate model to explain the world. So there are simple models like in statistics. That simple models are interpretable. They have this good thing. And there are more complex models which perform better in practice. Like, large language models is like Gemini or ChatGPT or Cloud called large language models. So yeah, machine learning is a very broad area where people from statistics and computer scientists are trying to develop the algorithms to explain, to generalize over the data or take decisions.
Sure. So, what we just talked about and what you're sharing is machine learning is a very broad discipline.
Mhm.
And I'm sure what we just talked about in terms of contextual algorithm,
Mhm.
I think is a subset of machine learning. Would you say that?
Yeah, yeah. So it's a subset of the decision making algorithms. There are some
Okay.
other algorithms which perform predictions, but in a static way.
Oh,
When you classify, for example, images, that was the first example, the classification, when researchers before, I think, 10 years or more, use very deep neural networks to classify images, like cat or dog. That's the classic example.
sure.
So this is a static problem. You
Mhm.
just take an image and you classify. And usually decision making is like an online problem. You take multiple decisions and you learn in an adaptive way.
So what you're saying is that there's different types of
Machine
algorithm,
learning.
yeah,
Yeah.
algorithms, which is there's like classification, there's decisions, there's prediction. You're saying?
Exactly. Yeah, that's
Okay.
exactly true.
Okay. Now, given this, and then one more thing about the algorithms as you're sharing, and for those of you guys who are listening to this, I know it's like really in the weeds right now, but this is super interesting, and I think it's still important for us to know just under the hood of what's going on. I think with AI, and so when you say so, going back to contextual algorithm, how do you determine which algorithm you would want to employ or I'm sure there's like sets of different algorithms that you could say I want to use this one. So number one, are there like different sets or different types of algorithm? Number two, how do you choose which algorithm to use? And then
Mhm.
three, who makes them?
Yeah, yeah. So that's a very interesting question. I will answer, from the academia side, which I think there's some gap with the industry one. In industry, they choose, like more which algorithm to decide to use and which one is the better. So usually people have access to some data. They collect data. Imagine the internet. There are many websites or applications which we use, and they collect data for the customers, for the users. And there are multiple ways to choose the best algorithm. One is like I have collected some offline data. I mean, offline is like upon choosing my algorithm, I create a simulation to see, like how my algorithm is performing comparing to benchmarks and this stuff. There are also some very sophisticated algorithms named model selection, which they have multiple algorithms and they start choosing the best algorithm in an adaptive way. And that's a very interesting field in online decision making. But I think, in practice, like doctors, or I don't know, like people in industrial engineering, know in practice which is the best one, which algorithm performs the best in the data they have.
Mm,
And I think in practice, there are a lot of heuristics that work, and there are not many theoretical results explaining why they work well. But, at the end, the result matters. So, yeah, heuristics are very important too.
sure. So what you are sharing is that to determine which algorithms are the best is you have some benchmarks and therefore whatever those sets are, whatever the benchmark is or the standard, you run simulations based on those algorithms and then there are certain algorithms that just do better than others and so you're like okay this one is better than this one then because of its results and the benchmarks and then you also talked about expertise, right? Some people just have been industrial engineering, so they just know because they've just been in the industry for a long time. And there's also algorithms that choose the best algorithms, which is very interesting. Okay, so I think I have a general understanding of like what contextual algorithm is. How would you say what we talked about so far with contextual algorithm? How does this then apply to what we see with ChatGPT or Gemini or these large language models? Do they connect in any way?
Yeah, sure. So, like in large language models, the context is the prompt you put in
Mm,
ChatGPT. And usually, researchers, when they have a new, when I say model, I mean, imagine we construct the new ChatGPT, then sometimes they have to fine tune, let's say, the large language model so as it has a desired property. For example, we want our new ChatGPT not to violate privacy. So we start using these algorithms, and the context is the prompt. Imagine we have some pairs of prompt answers. And the prompt probably is gonna be what's the address of Spiros. We want ChatGPT to say, I cannot provide you the answer, for example. That's one context. Another context can be the address is blah. So usually researchers, apply these algorithms, and the reward is one for the good answer that does not reveal our address, and zero for the other one. So usually researchers apply these algorithms to learn to teach the large language model this desired property. That's
so
one application, yeah, that is it's named reinforcement learning with human feedback. So the human feedback is, the preference upon the answers.
So it's reinforcement learning with human feedback. So what you're sharing is contextual algorithm that we talked about. Then the context that we're giving it this time is, so let's just talk about like AI privacy or privacy. I think privacy is a huge thing for people, and especially in education. They're like, oh my gosh, like a lot of sensitive information could go back and forth between students, teachers, whatever. And so we want to make sure that the large language models are fine tuned or the algorithms don't give away people's information, right? And so then what you are saying is that the context is what we give it. So for example, in this scenario was Spiros. What is Spiros's social security number,
Yeah,
whatever?
that's right. That's the context, and in this case, it's very private. But on the
Yes,
other side, if the prompt is what's the population of Boston, this is not private at all.
sure. So, given that it is private information or the context window is asking for private information, the algorithm then takes it and does stuff with it, I'm assuming. And then it says, and then there's like, I don't know, it gives multiple choices. It says, okay, Spiros's social security is this. And there's like, I don't know, 10 different responses it gives. And so a human literally goes and says, this is a good response, that's a bad, okay response, or something like that. And then
Yeah,
you just,
that's what's happening in practice. There are human labelers who are taking some considerable amount of money to do so. And companies are very interested in fine tune their large language models to, for sure, to protect privacy.
so what you were saying, okay, you mentioned about human labelers. So are these people who literally sit and then say good response, bad response, good response, bad response? Is that
Yeah,
what they're
yeah, exactly. And there
really?
are data sets in the internet, for example, where someone can see so. There's a website named Hugging Face, where they have done an amazing job about teaching developers how to use large language models, or they have collected many data sets, and some have this form: prompt, a pair of answers, and the annotation from the human labeler. Yeah.
Oh, wow. That's so interesting.
And I
So,
suppose there are data sets that are collected by the companies, are not revealed to the researchers. But usually, when a researcher is designing a new algorithm and is trying to publish the result of this algorithm, usually they have experiments on these data sets. And they say the performance of my algorithm is better, let's say, than the previous state of the art or something like that.
wow. Okay, so you're mentioning this website called Hugging Face, where
Mhm.
they give a pair of responses. So you put the context, and then it gives a response based on the algorithm that it's been chosen.
Actually, right, there's
Mm,
the dataset of
okay.
fixed prompts and pair of responses, and someone has already annotated.
So when you say annotated, is they were given some set of data that's fixed. So they're not just going into the internet where there's like searching for stuff. Is that what you're saying?
Yeah, so they are given two possible answers, like I can't tell you the social security, I'm sorry, and this stuff, or the social security is blah.
Mm,
And the human is responsible to say which answer it's preferable. Of course, the first one.
I see. And then from there, you can then the human labeler is saying, okay, this is a good response, this is a bad response. And over again, then the AI will, I guess, learn. So there's like more ones for this answer so that
Mhm.
when it's faced with a similar question or
Similar question. Yeah.
context, it will then give more weight to that one, to the response that received the most ones by the human label.
Yeah. So people, researchers are taking these data sets, they are using their algorithms to fine tune the LLMs so they can ensure some privacy. But never you can guarantee with 100%.
Oh, really? Okay. So when people say fine tuning, is that what they mean? Where it's like
Yeah.
there's humans
Mhm.
that literally say 1 1 1 0 and there's some annotation and reason?
Yeah, so this is one type of fine tuning, let's say.
Oh, so there's multiple different ways of fine tuning.
Yeah, that's the one I'm more familiar with. But maybe you want your LLM, let's say, to be good at solving math problems. You can fine tune it to be expert, let's say, on math. So there are general purposes, large language models, but there are some other ones which are specific for some tasks. Um, so yeah, upon creating your model, then you start fine tuning.
Okay, I have a question about, for example, how you would fine tune it would be small language model maybe for math, but I think for that one, I want to table it for now.
Mhm.
I think the question that a lot of educational leaders might be thinking about is this idea of who gets to determine what is a good response and a bad response. So, like for example, when it comes to the address stuff, yeah, it's like pretty knowledgeable that you should not. It's pretty widely consensusly agreed upon that you should not give out somebody's address to whatever. But when it comes to other information or other data, when it comes to I don't know social issues or whatever, right? It's very gray, right? So how are these people, these laborers, given like, hey, these are the ethics that you should follow? Is that what is there given like a rule book or principles, or how do they make that
So I
ethical decision?
think that, like probably there are some ethics and some like laws, probably federal laws. And, when you publish your model, you have to obey. And there are, for example, algorithms where you can say, I prefer this answer or this, or you have the right to abstain and say, don't want to label this pair. And like these algorithms take into account that this prompt is in the gray area.
Oh, interesting.
And probably, like if you want your algorithm to be robust, you may have a more, how to say, to satisfy privacy even in these gray areas.
I see. So the human learning reinforcement, I think, yeah, human reinforcement learning is
Yeah.
yes, no, or gray area. Don't know.
There are algorithms that work in that case too. The labeler wants to abstain.
Interesting. Okay. So then you also said then that it's not always 100%. Like you cannot guarantee. Why
Mhm.
do you say that?
So these models are very complex. So in order, like to guarantee, I think that's my personal perspective, but in order to guarantee, let's say, privacy, you have to develop some maths and give a proof. I think that's, the only clear guarantee someone can make. So these models, like large language models, are so complex. So it's really hard to develop maths that can guarantee with probability, let's say one, that the violation will never happen.
You said moths?
Yeah, maths, write proofs and theorems.
Mm-hmm.
Let's say, for example, this large language model, upon deploying this algorithm for, let's say, fine tuning for privacy, will never violate, let's say, we define privacy with some with probability as close to one as you want, for example. This is very hard. So they are not maths, and what usually happens, they are datasets like benchmarks, where they say, okay, we apply this, we use this dataset for our large language model, and it didn't violate privacy with accuracy 99.9%. But you will never know. I can construct an adversarial dataset that I can make poor performance for these large language models. I'm not sure if you have heard, before years, there were some models named neural networks which classified images. And some researchers have developed methods of modifying the images using some noise where the human can still say that this image is a turtle, for example. But the neural net classified upon injecting malicious noise as a gun, for example. So that was like, I think that's named adversarial attacks.
Adversarial attacks. Oh,
Yeah, and
interesting.
researchers are very interested in developing robust models to adversarial attacks.
So, what you are sharing, first of all, about the certainty. So, certainty would be one, which is 100%. With certainty that you cannot guarantee, because I'm assuming it's based on probability and to have, and the complexity of just the algorithms is just way too complex. And so in order for you to have 100% one certainty of a certain output is impossible. Or maybe impossible now, maybe some in the future it could be figured out. I don't know if it's mathematically even possible. But for now, it's not one. And you gave an example. It's called adversarial attack, where you gave us some noise. And when you say noise, I'm not assuming it's like actual noise, right? It's some weird data noise that you inject into the
Yeah, so by
image.
saying noise, they go to the pixels, for example, of the image. They add some small values to the pixels. That's why they call them noise. Humans can still distinguish the image. It's like the television, before years, let's say before 20 years, where sometimes we have some noise and some pixels were like white, if you remember, in the television. That is called noise. We could still distinguish what's happening in the television, but there's some corruption, let's say, from the signal that times. Yeah.
Oh, very interesting. So we can imagine a scenario where, given certain images, an adversarial person can potentially manipulate certain like pixels of that image. And even though it might look like a turtle, it might interpret it as a gun.
Yeah, that's true. And that happened to ChatGPT too. So I think in the beginning, now they have resolved that. But I know there are people that are still working on that. For example, someone asked this prompt, how to make a bomb. And ChatGPT told, I can't tell you like all this stuff and these details. And then he asked the same prompt and he added at the end some random letters, let's say. So these letters seemed random to us, but they came upon some heuristic or some optimization problem, and then the ChatGPT answered how to make a bomb. So that's an adversarial attack, for example, in a large language model. And I know that there exist at least some startups who are working on that. How
Wow.
to You make the models robust even to this type of attacks.
So adversarial attacks, I'm sure is a okay. So I would imagine that it is a pretty big issue, right? And especially because people can potentially use AI for malicious purposes. So, like, even when I didn't ask this question, but I think two ways I want to go about it. So, the first one is just more of a national security reasons, but also for number two is for our students, right? Because students, if they want to find out how to make a bomb, using, I don't know, like Google Gemini, which they all have access to because the school bought it for them. So then, like, for example, so what you're telling me is that there is a possibility where some adversarial person right now is training a model to be malicious, or not even malicious. It's like they can potentially train a model privately where it's like unhinged, where literally like whatever you ask it, it's gonna give you a response, and there's no blockage whatsoever. Can somebody design something like that?
I don't think they design something like that, but imagine for ChatGPT, when it's published, they are trying to fine tune to be, robust to this type of attacks. But actually, it's a very hard problem. That's my statement. Because imagine the attacker has many chances, is trying many times, let's say, to hack the system, while the system has only one mistake for the system is really bad.
Mm,
Afterwards, they published ChatGPT, gave me this answer, or blah blah, whatever. My statement is that it's a very hard problem, that our people are working to make these models robust always, because attackers have many chances and models have to pay a lot even for one mistake.
I see. So even one mistake could be huge, right?
Yeah, that's
Like
right.
if somebody does something really bad based on
And that's true for many other systems, like AI systems. Imagine Tesla. One mistake for Tesla
it's
is
game over.
catastrophic. Yeah. So they want, like when they publish these models at public, they have to be more than 100% sure that. And I'm not sure if you have seen now. I saw recently that people managed to fool Teslas by wearing T-shirts with a stop sign.
Yeah.
And that's something that when someone designed, let's say, the autopilot in Tesla, didn't think about.
So I think the one of the big takeaways for me, just as a human being, and then maybe applied to education, is for educators to really know this, right? And for teachers and district leaders, for them to know that AI will never, or at this point, will never be 100% like safe. Like if, for example, if there was an adversarial person, whether it's a student, whatever, and they really wanted to attack it and hack the system in whatever way that they want to, there is a, though slim, but it is a non-zero chance that this can
Mhm.
happen. And so I think it's very important for us to acknowledge that's the case. I don't think a lot of people know that actually. I think when,
Yeah.
yeah, go.
Yeah. Sorry. Go for it. Yeah.
Yeah, I don't think a lot of people know this. I think like even me, I was like, I mean, I kind of had an idea, but when we tested it or like we just said like a bad word to it or something, it always responded very kindly, so on and so forth. But after talking to you, is like, wow, there is a chance if there is a slim chance where a student can do something very harmful. So then let me ask you this, because I guess this is more of like a ethics questions from your opinion. If there is a non-zero chance, but that chance is so low, I'm assuming it's pretty low, right? Like there has to
Yeah.
be
Yeah. It's
somebody,
pretty low,
yeah,
and usually it doesn't happen by chance because, for example, the what I told you before about adding these random words came from a researcher who thought about an optimization process and, went through the mechanics behind. and manage to do so. But I don't think, by, let's say, something at random, it will succeed with some reasonable chance.
Sure. Yeah. So what you're saying is that unless there is a person with clear intention to use it for adversarial purposes, most likely it's almost certain that it will not produce something that's detrimental
Yeah,
to the
that's
user.
that's true. Yeah.
Okay.
For example, I can say other things that we use in an everyday basis that are there are some proofs, let's say, using math that are not, let's say, hackable. Our credit cards. There are proofs, like cryptographers have deployed a math theory behind, and they say that we use this protocol, and this is not easy for anyone who may have access, to all the computational power they need to hack and learn our, let's say, password or credit card. For example, for AI, there's no like, it's a more complex system, so there is no any math proof for that.
Oh, interesting. So you're saying that with credit cards, there are certain mathematical proofs that make it certain that it's not hackable with cryptography, so on and so forth. But when it
Yeah,
comes to large language models, because of the complexity, right now, there's no certainty with anything, though very small.
yeah, yeah, that's true.
Interesting. So thank you for just sharing everything about human reinforcement learning and just AI ethics too. And I think we do have just a couple more minutes left here. First, I mean, I just so enjoy this conversation.
Yeah, me too.
Let me ask you, and I've talked to some people about the future of AI, and most people just they don't have any idea of what the future of AI is going to look like because it's developing so fast. But in your opinion, and what do you think AI is going to be like in the next 5 years, maybe 10 years, or whatever time frame that you think significant for you to just kind of choose and talk about? And then maybe I can talk about what that would potentially mean for teaching.
Yeah, so that's a very nice question. I've thought about it many times. I think it's hard even for, the real experts to answer that. That from a student's perspective, I think, like people are trying to develop, let's say, to reach artificial general intelligence. Because now you see, for example, ChatGPT maybe is very good at one task that we consider difficult, but is not good at all at something else. So this is not general intelligence, like humans have general intelligence. And so I think that's what people are trying, and many researchers believe that they will not succeed this goal using transformers is the current technology behind large language models. But this is something very general. May someone agree or disagree with that. What I thought sometimes is what's going to be the future of computer science. I think quantum computers will arise in the next years, and that's going to be fascinating because it will change the whole view of computer science, in my opinion. And I think that's a field in computer science where the theory is more developed than the hardware. It's the only one. While and yeah, I think for sure there is a much more space for things to be developed, like cryptography or statistics. And I think computer science is a great field to study. And it's not only about, let's say, programming. So I think for students, it's like a fascinating field that is emerging and is progressing every so and while. And anytime, like I think any period of, let's say, my life or let's say my parents' life, someone studied computer science, they believed that they studied during a breakthrough. Yeah, and that's fascinating. I think that's, I don't know, what's your opinion about that?
Yeah, I mean, you mentioned a lot of stuff, which I'm so curious. Like, I would love to hear one day your opinion on AGI. And I want to get more like specifics on what AGI actually means. but that's another topic. There's quantum computing, and that effect on computer science, also AI and cryptography. You also mentioned statistics, and then it's just two questions I think before maybe we could do two. I don't know. We'll see at the time
Yeah,
here.
let's yeah,
But
let's
you said you talked about the quantum computing. If you just had to give like a super short blip on what quantum computing is and how that's going to affect AI, how would you describe that? Because my understanding of quantum computing is just it's just the processing power of something is becomes almost infinite. I mean,
not
that's just
not
yeah.
infinite. For example, using a quantum computer, there are still proofs that someone cannot hack your credit card
Oh, interesting.
or internet protocols or this stuff. So it's not infinite. It's gonna be much more than the computational power we currently have using our computers. And like AI is actually statistics applied to some computational model. Let's say in this case is like a neural net or a transformer for large language model. And then if you change your computational model, like your computer actually, and you use a much powerful one, you may, achieve greater things. But it's not, let's say, infinite. And yeah, what's the limits of I think, like AI using quantum computers, or I think it's very interesting. Then you have to redesign a lot of your algorithms in the quantum model, quantum world. And that's also like a fascinating direction. And yeah, I'm not an expert in quantum computing. That's I think that I have to think about it and study more in the next years. I see that coming. Yeah.
Yeah, that's awesome. And yeah, quantum computing, I did hear. So my understanding is that it's very powerful, meaning that it could compute maybe a lot more, but it's not infinite. And we are going to have to redo a lot of our systems within the world of quantum computing. And then you then also share that computer science was emerging. Now, in the educational world, computer science is equivalent to not completely equivalent, but my understanding, a lot of it has to do with industry in terms of tech, right? Whether it's Face or Meta or Google and Amazon, it's creating like apps, right? But I'm sure that the discipline of computer science is a lot deeper than that, and it goes like kind of what you are doing. And so you're saying that it's emerging, where in reality, it seems like the job market for computer science is like has people say that the computer science or software engineering market has exploded, like the bubble has finally exploded of sorts, because nobody's getting hired as computer science majors. At least that's what I'm seeing. I could be wrong. So when you say that it's emerging, tell me more about what you mean by that.
So I think, now using these tools, a student and even, like a PhD student or a researcher can learn more things using, let's say, Gemini or ChatGPT. But there's the caveat of like your teacher, like the large language model, to throw you like wrong answers or to be unsure. So you have to develop, let's say, the critical thinking, and also like from the other side, the knowledge is summarized using these tools, and you can learn more fast. So I think for like students who like learning and like problem solving and this stuff can develop more skills faster. And I think the job market is going to adapt to that, and people are going to ask you, let's say, different tasks in the future, or let's say using the LLMs in a correct way in learning. I think it's going to be a skill that's it will be necessary in the. So I think in universities, for example, they are trying to convince the students to use the large language models, but in a way to learn actually what they are writing as solutions. So to do this, maybe they have, like more exams, physical exams, or let's say sometimes they have to present their solutions or this stuff. So from one way, like you cannot always have access to your teacher, let's say at home, or maybe during the class there's some parts you didn't understand 100%, you couldn't join the office hours or whatever. Nowadays, you have access to something that when it's using in a meaningful way, you can accelerate and learn faster.
Yeah. That last part is something that I'm very interested in, which is what does it mean to genuinely learn for students in the age of AI? And I have an idea and my own thesis around it because I have used AI to learn a lot of things. And I think that that is going to be a conversation for next time.
Yeah.
And one last question. And if you had to just give one word of hope and encouragement for educational leaders, just from a PhD candidate, right? What is your one word of encouragement to them?
I think like they should use AI, learn to use in a fascinating way, not to be afraid that a lot of tasks they are doing can be accelerated. They can never, like replace their expertise and their multiple years of experience. And they have to learn this, to teach the students actually to have the joy of learning when you solve the problem on your own or you use the model in a meaningful way and you do steps and progress to have this like amusement. So using this way, a student using the LLMs this way can always be happy and satisfied and try more to do more progress to learn more things. I think like educational leaders should take that into account and like diffuse the passion for learning to the students.
Absolutely. Thank you for sharing that. It's a message that I think is very timely for leaders is to be exposed to AI, to listen to podcasts like this, where it's geared towards educators and where they can learn about, hey, it could, there's a non chance zero that it could do adversarial things, but now
Hmm.
you know. And so you have at least an idea of its potentials. And now when you're using it, that's something that you can communicate to your students and also your district and being aware of these potential pitfalls and and yeah, and like you said, it's about the joy of learning, meaningful deep learning, where students can come to their own conclusions and also accelerate their learning and their productivity. And thank you so much, Spiros, for your time.
It's a pleasure. It's a
It
pleasure to talk
really
to you.
was fun.
And
And
some message for the students: they
yeah,
never
go for it.
know. They
Yeah,
may close the gap and guarantee privacy with 100% probability.
sure,
Yeah.
absolutely. Yeah, I hope that they close the gap with privacy, and that's something that yeah, I'm sure people are working on. So yeah, once again, thank you so much, Spiros. I appreciate your time. I hope that we could do this again
Yeah, yeah.
because it
It's
was
my
such a
pleasure to talk
pleasure
to
and
you. Yeah.
yeah, it's super fun. Okay, I'm gonna go ahead and stop the recording. Okay, or bye everyone. Bye. Thank you for listening.
Bye.